So last week we just did a brief introduction into what electronics are and what a circuit is. This week we are going to be talking about the Arduino, which is the microcontroller that we're going to be using throughout this semester, the main one. I'm perfectly fine if you guys want to use something else, like a Raspberry Pi or something too for your assignments, but this is the one we're going to focus on in class. So today we're just going to do a little hello world, kind of break down the Arduino, talk about what it is, how it works, what's on the board, and then also talk about the programming environment for Arduino, which is a web-based programming environment. They also have a local one that you can download, but it makes more sense since we're doing this remotely that you work in the online environment so you could share your code with me a little bit more easily. So we're going to talk about that, and then we're going to talk about go over some demos on how to get the Arduino working with a circuit. So like blinking an LED or hooking it up to a button to control an LED. So we're just going to kind of cover the basics today, and then next week we're going to go into a little bit more depth of analog inputs and outputs, and I'll talk about what analog versus digital means in this world a little later today. So let's go ahead and jump into it. So microcontroller. So the Arduino is a microcontroller. There's lots of microcontrollers out there, and a microcontroller is just basically a very simple, sometimes not so simple computer that can process the basic tasks of listening to sensors and interacting with other components like motors and LEDs and screens and whatnot. So there are tons of microcontrollers out there. And the brains of all these microcontrollers is the chip on it. So there's different sizes. The one we're using is about this size. Actually, this is the one that's on the Arduino. There's microscopic ones that are really teeny. So these are kind of the brains behind the microcontrollers that we're using. So when it comes to the Arduino, this is the microcontroller's processing chip. It's called Atmega 328. So you could actually buy this chip and make your own Arduino. I'll show you an example of that in a second. But each one of these pins on this chip is basically connected to one of these inputs on this board. So we're basically just making it a lot easier for us to connect to these pins using just wires that we're plugging into these inputs on the board. So the basics on the board are these inputs or outputs. The ones on the right hand side are numbered from 0 to 13. These are all mostly digital inputs and outputs. Digital meaning just true or false, 0 or 1, on and off. So it's just one option or the other. There's no gray area in between. There's no range. So it's basically saying, okay, is an LED on or is it off? That's digital. Or is a button pressed or is it not pressed? That's digital. That's just two options. On the left-hand side here, where it says A0, A1, etc., these are analog inputs. So analog means that there's a variable number of options that you can get from the sensor. So that could be like a knob, or we call them potentiometers. So the A0 through A5 over here are analog inputs, and analog basically just means it has a range of outputs from the sensor. So for example, like a potentiometer or a knob has a range of, I think it's 0 to 255 for the value. So instead of being digital, which is just like 0 or 1 basically, analog inputs can have a range of inputs. So that could be a knob, it could be a like photocell sensor that gauges the amount of light. It could be a temperature sensor. It could be a moisture sensor. So all of those sensors are analog sensors that can give you a range of values rather than just on or off. So those sensors would be used and inputted into the analog in ports over here. And then above that, we have power outputs and ground inputs. So you can do 3 volts out, you can do 5 volts out. Then there's 2 grounds here. And then VIN is voltage in. So if you have like you can power the Arduino with like a 9-volt battery, I believe, or a like 12-volt power supply. So you can use that voltage that's going into the input here and use it for your projects as an output as well. So this is an optional power supply. So you can plug in a 9-volt battery here. I think go up to 12 volts. This is the USB. This is the USB input, so that's how you can also power it, and it will get 5 volts from the USB cable coming from your computer. And it's also where you are going to want to plug it in if you're uploading your code to the Arduino board. This button is just a reset button, so when you press that, it just resets the Arduino. And these are some lights. I'm not sure what the L represents, but the RX and TX, those are whether you're sending or receiving data to or from the Arduino. These lights are going to be on and blinking. This light is a power light, so once you plug it in or once it's getting power, then that's going to turn on. I gotta look up the L. I'm not sure what that represents. And then we're going to talk about the little squiggly line here. It stands for PWM, pulse width modulation. It's basically, we're going to talk about it next week or the next time we meet, but it's basically kind of like fake analog output. But yeah, we're just going to talk about digital today, and we'll talk about analog the next time we meet. So like I said, the Arduino, the chip is the Atmega chip, and this is can be purchased on its own. So you could actually make your own Arduino as long as you can get the Atmega, was it 368 or whatever, chip. You can make your own Arduino. So there's examples down here where you can just kind of breadboard it. There's also examples where you can create your own circuit board and solder all the components to it. And I think to make this, all the components cost about $5. So it's a lot cheaper to build your own Arduino than buy one from Arduino. But it's just a little bit more complicated to build your own. So maybe after this class you might be able to have the confidence to do that. But the great thing about Arduino is that it's completely open source. So even if you build your own, you could still use their programming environments to upload any code to this Arduino. So it's pretty great. Okay, so this is just an example of how the board is going to be set up. So we have the breadboard over here, and then the Arduino over here. We're giving power from the Arduino to the breadboard. So the 5 volts cable is plugged into the power rail. The ground cable is plugged into the ground power rail. And the power and ground is coming and going to the Arduino itself. And then into the breadboard. We also have these cables that are connecting the power rail from left to right. So we could use both sides for power and ground. We can plug in our components, use our resistors here, and then plug ground into ground, and then plug the power into the Arduino. So then we can control the LEDs and read data from the button on the Arduino itself. So this is a basic circuit that allows us to control, with a button press, these LEDs using code that we wrote and uploaded to the Arduino board. So
sorry.
Oh, sorry, go ahead.
Yeah, does the placement of everything matter? Where you put like the little, I guess, holes in the breadboard, like, does that matter?
It matters to an extent. So as long as like power is connected to power or the Arduino output or input, and then ground is connected to ground, that's what matters. So as long as the circuit is correct, that's all that matters. But like the position of like what row this is in, or
like the numbers on the side, does that matter?
The numbers and the letters at the top on the breadboard are just for you to use as reference, so you know what's plugged into what area. But yeah, it doesn't matter beyond that. It's just like a reference point for you.
Got it.
But we're gonna put together some circuits today and upload some code to the Arduino boards and get things actually working. So we'll do that in a minute. Any other general questions about the Arduino? Or the breadboard?
Okay. If it's under 5 volts, you don't really need a resistor, right? Or you should anyway?
I mean, it depends on the component. For an LED, I mean, if it's like if you're using 3 volts instead of 5 volts, it's probably okay not to use a resistor. But if you really wanted to figure out like what to use, if anything, then you can kind of do the math for it. So yeah, I guess the answer is it just kind of depends on the component that you're using and how much power you're sending to it. But honestly, the worst thing that could happen is that it just kind of gets too much power. For an LED anyway, it just gets too much power, and then it gets burnt out, and it can't be used anymore. I guess I mean, if you give it like 12 volts, like straight, then it might short circuit and maybe melt the LED, so that wouldn't be great. But the amount of voltage that we're working with from the Arduino won't most likely do that. So for 5 volts, I'm using like a 220 ohm resistor, which is red, brown, gold. It might be a little different in your kit, to be honest, because some resistors have different number of lines and different colors on them, but still represent the same value. So just be aware of that. Okay, so when it comes to working with the Arduino, so we have some sort of input that could be like a button, a motion sensor, sending data from a computer to the Arduino, and then it's being processing that data that's collecting from the input. And then based off of that data and the code that we have on the Arduino, we determine what the output's going to be. So that could be either like blinking an LED or turning on an LED, or running a script on your computer or something like that. So all the code is going to be uploaded to the Arduino and kind of live on this chip. And then any input is going to be taken and interpreted, and then based off of that input and based off of the code, you're going to get a different output. So the next thing I want to talk about is the Arduino Programming environment. So there's 2 options when it comes to Arduino. There's the local environment, which is on the left, which it's like a piece of software that you download to your computer and then use it locally on your machine. And then there's a web environment, which is what we're going to be using for the most part in this class, unless you have like issues with it for some reason. So the web environment is great because it allows you to go to any website, go to any browser, go to your Arduino account, and then you can save all of your sketches, all of your code in your online account. So it's accessible on any machine. So I think it's probably a better environment to work with. Sometimes people have issues with it, so I use the local environment as a backup if for some reason you have issues on your machine. But let's try and get this working on the web environment. To get access to this, you just go to the Arduino website, so arduino.cc, and then click on Software at the top. So you guys can kind of follow along with me with this and get it working. Just have to log into the Code Online option here, and then create an account, and then you have access to the environment. You probably actually should go to Get Started first, because there is a little plugin that you have to download and install on your machine. You could, if you already clicked on Code Online now, that's totally fine. You could do this at any time. You just need to do the Get Started bit first to have your computer and browser recognize that the Arduino is plugged into your computer. So once that plugin is installed, then you'll be able to connect to your Arduino from the browser programming environment and upload your code to your Arduino. So once you're in that environment, this is kind of the breakdown. So we have toolbars over here, actually, and it shows you that the Arduino is connected or not here. There's tabs for your code here, so you could have different documents attached to the same project. This is the text editor where we actually write our script and write our code. This area is the message pane area, so it's going to show you like successful checks or successful uploads, as well as any errors that might be in your code. This is the menu area. We'll talk about each one of these in a second. And this is a sub-menu option when you click on each one of these menu options. So for those of you who had taken my creative coding class in the past, it's very similar to the P5.js web environment that we used in that class. So there's a lot of similarities here. And same thing if you do processing and download that and look at it versus the downloadable environment for Arduino, it's very similar. There's a lot of kind of the group of people that work on Arduino and processing kind of run in the same world, so there's a lot of overlap there. And processing can actually work with Arduino and vice versa, so you can write code in processing to work with Arduino and code in Arduino to work with processing. So that's just kind of a side note. So the message pane, so at the bottom, if it's in green, then it's a success. It just gives you some just general information, some messaging on what happened, whether it was like an upload or just checking your code. Here is just what it looks like if there's an error message. It's going to be in red, and it'll probably tell you where the issue is in your code. Hopefully. It doesn't always tell you, and you kind of have to figure it out and decipher it. But that's the message pane area. So the menu area, so there's the sketchbook. This is where you save all your sketches, all your code goes here. And you can create folders and kind of keep organized. At the top, there's a new sketch button, so you can click on that to create a new sketch. Next to that is the create a new folder button, and I think this is a download or output button. Below Sketchbook, there's the examples menu, and this is a great resource for you because there's tons of examples in here, like pre-written code. So you can click on each one of these and kind of take a look at it. and see how to write the code and just use the code as is with whatever project that whatever circuit that applies to it as well. There's libraries too on top of the Arduino environment. People have written libraries and attachments that you can use as well. So if there's something that's not a part of the core Arduino environment, there's probably a library or a plugin that you can use for that particular project. This is called the serial monitor. So the serial monitor is great because you can print out values that you're receiving from the Arduino. So if I want to know, like, if I have a light sensor plugged into the Arduino and it's reading the values that that light sensor is getting, I can see what those values are in the serial monitor area, and then determine what to do with the values. So usually for that, I'm trying to figure out what like the min and max values are for, like, let's say a photo sensor, a light sensor. So if it's between a range of like 0 and 20, then I know that I need that's the values I have to work with. But sometimes it could be a range between 0 and like 1,000 or something. So you just have to print out those numbers to help you determine how to use them properly and how to use that sensor properly in the environment that you're in. Reference is basically just the reference library. So these are all the functions and values and variables that you can use for the Arduino programming environment. So you can click on each one of these to learn more about, like, what is digital read, what is digital write, what is pin mode. So it's a great resource for you to better understand what these functions and methods are when it comes to programming for the Arduino. Yeah, and this is kind of the basics behind the text editor. So we have a void setup and a void loop. So these are two functions in the Arduino programming environment that everyone will be using. So void setup, anything that just runs on load should be put in here. So it just runs once, basically. So that could be like defining a pin to be an input or an output. That probably just needs to run once. Versus like void loop is just looping through this code in between these two brackets infinitely. So if you want like an LED to be blinking every like second or so, then that code would go in here and it would just constantly turn on and turn off every second.
So I have a question. Are we gonna add like audio into this into these into one of the projects, or is it like more like switch based or?
Yeah, I mean, when it comes to what you want to build and the projects that you're trying to kind of produce in this class, it could be anything and everything. So if you want to play around with audio, whether that's an input or an output, you can totally do that for your projects.
Oh, okay. And I have one more question. I'm sorry.
Yeah.
So I know, like, in design, it's like the sound that you use is like it shouldn't be copyrighted, but does that matter for this class? Like, let's say for example I use like a Pikachu sound for one of the projects. Is that possible, or? Yeah.
As I think if it's used for educational purposes, I don't think copyright's a major issue. It's only an issue if you're trying to like sell the product or make money on it in some way.
Oh, okay.
That's my understanding, but I won't turn you in. But yeah, so you can work on any type of project and use any type of input or output for projects you do work on in this class. So yeah, it could be really anything you want. Programming for the Arduino, I'm gonna try and keep it as simple as possible in this class because everyone is, for the most part, most of you guys are beginners when it comes to both physical computing and programming. So this is kind of this slide kind of covers everything that we're gonna be talking about and using in this class for the most part. So all of these functions and variables are really what we're going to focus on. So we just talked about setup and loop. Those are kind of the core functions when it comes to Arduino. Then there's functions like pin mode. So that's determining or defining whether a pin is an input or an output. So like the 0 through 13, you have to define those as either being an input, like for a button press, or an output to like turn on an LED or something like that. And then there's digital read and digital write. Those are reading, like a button press is a digital read. So you have to determine if it's pressed or not. So you have to read if it's high or low, which is high is basically means pressed, and low means not pressed. Digital write is just writing to like an LED or an output of some kind, a digital output of some kind. And again, it's just using high or low to basically turn on an LED or turn off. So it's basically giving it power or not giving it power.
Make a cool switch that'll light up an LED. And so I was like, what do I do? What do I do? And I don't know how I...
And then analog read, analog write. It's just the same thing as digital read and digital write, but instead of digital, just on or off. Analog is a range of values. Delay, you can put a delay in your code. So if you want an LED to blink like every 3 seconds, you can put a 3-second delay when it's off, and then a 3-second delay when it's on. Mapping values, that's more, we're going to get into mapping next time we meet, when we play around with analog inputs and outputs. But basically you can take a range, whether it's like 0 and 20, and then remap that range to be something more appropriate for like an LED, which would be something like 0 to 255. So it's just remapping min and max range to a different min and max range. But we'll talk about that in the next time we meet. And then serial begin is just a way for us to start the serial monitor and send data to the serial monitor. So those are like the core functions that we're kind of be using in this class for the most part. And a function, for those of you who don't know, is just it's kind of like kind of pre-written code that you can put values into and get different outputs based off of the values you input. So that's all a function is. It's kind of like a box that has an input, so you throw stuff in the box, and then when you take it out, it's going to be something else based off of the code that was in the box. And variables. So variables are actually, sorry. These might still apply, but so variables are kind of like keywords that you can define that represent something else. So you could say a variable name and then equals 0 or a value, and then use that variable everywhere it's in your code, and everywhere variable name is used is always going to be equal to 0. So these are you can create your own variables like that, and this could be any name as long as it's one word. The int, float, boolean, and string, this is used for the local environment. I'm assuming it's the same for the web environment, but it might be different because it's probably JavaScript based. So we'll figure that out later. I'll test some stuff to see what works. And then below this here, these are variables that come standard that are part of the Arduino programming environment. So there's high and low. That's basically saying high is saying like turn on an LED, low is saying turn off an LED. or high could be a button is pressed, and low could be a button is not pressed. Then there's inputs and outputs. So whether you're using the pin as an input or an output for either an LED, which is an output, or a button, which is an input. And then true and false are just standard variables that come with Arduino. So those are variables. These are some examples using these functions and these variables. So for pin mode, let's say we wanted to use the pin number 3 on the Arduino, and we want to use that as an output for like an LED, then we have to define that pin mode 3 as an output. For digital write, we can write high to pin 3 to the LED, which is going to send power, send voltage to that LED because it's set to high. And this is just an example of a map function that is taking a min value of 300, a max value of 750, and then remapping that to be a min value of 0 to 255. This is a little hard for some people to grasp sometimes, so again, we're going to talk about that next time we meet in more depth. So the next thing that we're probably going to be using are conditional statements. Conditional statements are basically asking a question. If something is happening, we want something, this other thing to happen, else we want another thing to happen. So that's what conditional statements are. They're like asking a question. So here I'm asking if input equals high. So let's say if a button is pressed, then I want to do something here. So I want to put code here when a button is pressed, and we'll run that code. Else, which basically is the opposite. So if the button isn't pressed, then I want to run this code inside these brackets. So those are conditional statements. You can have else if too. So if you wanted to have multiple, so if you had like multiple inputs, like 3 buttons or something, you'd say if input equals 1, do something. Else if input equals 2, do something else. And then else is just kind of like if input equals anything else, then do run this code. These are comparison operators, basically saying, so here we're just using equals equals, which basically means is input equal to high. But you could also do is less than a value, is it less than or equal to, does not equal to, is greater than or equal to. So these are the other options I can use instead of this equals equals sign. And then there's other operators, arithmetic operators like modulo, multiplication, addition, subtraction, division, etc. Which you could also use just for like basic arithmetic stuff. But most likely you're not going to use very many of these for your projects. Okay, so that's kind of the basics of programming for Arduino. You have your functions, your variables, and then you're most likely going to be using conditional statements to determine like if a button is pressed, then turn on an LED or run a motor or something like that. If it's not pressed, then turn everything off. So that's kind of a conditional statement when it comes to physical computing. Does that make sense? It'll make more sense once we start like writing code and like getting our kind of hands dirty with the projects that we're gonna do. So I think right now it probably doesn't make 100% of sense to you, but once you start building things and sending code to the Arduino and seeing how it interacts with the circuits that we're putting together, I think that'll kind of turn the light bulb on for you. All right, so why don't we all kind of work on these together? So hopefully you guys are set up with the Arduino environment, programming environment on the website. And now let's go ahead and kind of put together a circuit, plug the Arduino in, and write some code to play with that circuit. So this is the circuit that we're going to build. So it's very basic. We have an LED. that LED is connected to ground here. And then also we're using a resistor here. This is a 220 ohm resistor. It's red, red, brown, gold, which is then connected to the Arduino for pin number 3. And the Arduino is also connected to the breadboard for 5 volts and also ground. So let's go ahead and put this together. I'm going to leave this up while I put mine together. And remember that for the LEDs, the long leg, the long lead is goes to power or the Arduino, and the short one goes to ground. So let's go ahead and put this together on the board. To complete the circuit, the LED needs to be connected to the Arduino and then also to ground. So that black wire is connected to the ground leg of the LED. Remember, it's polarized, so there's a positive and negative side. So the negative side, or ground, has to be connected to the ground of the Arduino. So if you kind of trace this back to the black wires, it goes to the ground input. Alright, so your board should look something like that for those of you who are still checking them out. Alright. Okay, so these are... okay. So the blue ones in the kit are the 220 ohm resistors. So yours looks different than mine. So mine is the red, red, brown, gold. But yours is the blue resistor with red, red, or the black, black, brown.
Yeah, we have a resistor color code paper.
Oh, you do? Okay, cool. Sorry, I should be using that then. Okay, I'll use the blue resistor. Okay. Alright, so everyone have that kind of set up?
Professor, I have a question.
Yeah.
When it comes to the Arduino and connecting it to the breadboard, it's just one. It's the 5V to the power. And is there another one, or just, I can't tell because my computer is kind of like blurry right now. I'm running on my mobile hotspot, so it's like it's kind of hard for me to tell. Everything's just a little blurry.
So the breadboard connected to the Arduino. Yeah, the 5V is on the left. And then there's a couple of grounds, so you have some ground options. So there's 2 grounds below that 5V on the left-hand side. There's another ground above the 13 on the right-hand side, which I'm using, that one actually.
Oh, okay. All right. Thank you.
Sure. Yeah, so again, you can use, there's 3 ground options, so you can use the ground here on the left-hand side, or you could use the ground on the right-hand side. And then there's just one 5-volt output that we're using to power the breadboard. I mean, technically, for this circuit, this very basic circuit, we're actually not even using this 5-volt power for the circuit itself, but this is just kind of like standard way to hook it up to the breadboard, just so you always have the option to use the power. But we're actually getting the 5 volts power from the 3 when our code tells it to output 5 volts to the 3. Alright, so let's go ahead and look at the code, and we can come back to this slide if we need to later. So this is the code that we're going to be writing in the Arduino programming environment and then uploading to the board. And basically what's going on here is in setup, we're defining the pin mode for pin 3 as an output. So we're going to send power to that pin for the LED. Then in our loop, we're going to say digital write 3 high. That turns on the LED. That's giving it power, essentially. We're going to run a delay for 1,000 milliseconds, which equals 1 second. And then we're going to turn off the LED after that 1 second. Digital write low to pin 3. And then we're going to run another delay and keep it off for 200 milliseconds. So it's going to flash and blink really quickly. And then we can always play around with these values for how long the delay is for how long it's on versus how long it's off. Cool. So let's go ahead and go to Arduino.cc and click on software. And if you haven't done get started yet, make sure you do get started. So you have to create an account. You have to download this plugin. And then you can start working with the web environment. So the most important part is downloading this Arduino web editor plugin. Is this it? Hold on. New platform. Okay. Where is the plugin? Okay. Let me find it a different way. So okay. So I found it in the code editor under help and download the agent. Okay, so here it is. So let me just put this in the chat. Okay, so this is the plugin that you need to download and install on your machine. Okay, so once that's installed on your machine, then you should be able to go to your web editor. I would probably reload the page just to make sure that that's all connected properly and refreshed. Okay, thank you. Okay, so in here,
do we connect your thing on the top to Arduino?
Yeah, so we're gonna do that in a second. I guess we could do it now. So at the top, let's plug in the Arduino to the computer. And then it should auto detect that our Arduino was connected. And then when you click on the select board, it should be able to find the port that it's plugged into and the name of the board. So then you can click that. And then the Arduino is connected. So this is our programming environment, our programming area. This is where we write all of our code. There's two tabs at the top. This is the main tab for where we write all of our code. This is just kind of a README document, just information about the code that you can, edit and update if you wanted to, but we're probably not going to touch that. You create new tabs as well for if you want to separate out your code to multiple tabs, you can do that. But we're probably just going to stick with one tab and code in just this one area. You can make comments in your code. So whenever you see this / and the I don't know what's that called, like star sign, and then ending it with the star sign / that means that there's you can write comments in there. So I could say Queens College Physical Computing Demo Week 3 Pane Woo. So this will be ignored by the Arduino when you run the code. It's just like, oh, can you guys?
Yeah, you stopped.
Yeah, it just switched to you.
That's weird. Okay. Okay, so you can write comments in here. When you're running your code, it'll just be ignored. So this is just for you, just to, like, as notes, essentially, for you to know what's going on. And then in setup, and you could also do this like everywhere. So in setup, we can say, okay, if you just want to do a line, it's just //. And we can say, okay, define the pin mode. And then we can say pin mode. And we're using number 3. And we want to define it as an output.
That happened again, your screen.
Ah, okay. Oh, you know what? It's because I have hotkeys and 3 is a hotkey. That's going to be annoying. Okay, let me fix that real quick. So we defined pin mode 3 to be an output. So the next thing we want to do is say, we want to turn on the LED. So let's say digital write 3, which is the pin, high. The semicolon is kind of like a period to your code. So at the end of every line of code, you have a semicolon there. And then let's go ahead and just upload this and see what happens. So the buttons at the top, there's a verify button, which is that check box button. And you can verify your code. So it'll just check your code to make sure that's correct. Yep, looks good. And then next to that verify button, the check button, there's an upload button. And then we click that, and we can upload that to your Arduino. And you can see the lights blinking on your board when you're uploading it to say that's receiving data.
What did the high mean again in the digital write?
So high means that it is getting power. Here we go. So high mean is it's sending power. So it's on, essentially. So here we can say, okay, send power to pin 3 to turn on LED. So if it's working properly, then you should have a LED that's turned on once you send the code. Anyone not have that? So this is mine. Mine was actually wrong. I had mine plugged into pin 2 by accident, so I had to make sure that was fixed. And then when I plugged it into pin 3, then it worked. You can also rename this if you want to. So I'm going to just rename this as week 3 demo.
Is this supposed to light up or no?
Yeah, it should turn on.
Oh.
Mm-hmm.
Cause mine says like everything's green and it saved it, but light bulb didn't turn on.
So it might be the connection. So maybe just double check that it's plugged into 3. Double check that it's on the right line as the resistor. the resistor is plugged into the LED and on the leg, on the long leg, and that the short leg is plugged into ground.
I remember I had one LED that stopped working, so maybe I put in the same one again.
Yeah, it could be that too. That's sometimes the fun part / really annoying part, is debugging your circuit. Need to get better lighting in here. Okay, cool. 22. Tony, are you okay? Is it working? Or did it stop working? Okay, cool.
Professor?
Uh-huh.
Does it matter which light that you use? Is the LED sensitive to the different circuits? Or is it not sensitive to different circuits?
Generally not. There are different types of LEDs, but what comes in your kit, they're pretty much all the same. But there's super bright LEDs you can get, which probably needs a little bit more power. But yeah, what's in your kit, all of them should be the same. So I could try a different one. Let me try a green one. Yeah. Yeah, as an alternative.
Another question that I have is in regards to, I don't have my laptop working, so I can't really inferring how this all kind of comes together. But with putting it into the computer and putting in code, right? Say, for instance, you have a problem with your circuit. Does it tell you on the application, or do you just have to infer when it doesn't go through it?
It doesn't tell you on the application. Doesn't tell you on the web environment. If you have any issues with the circuit itself, so you kind of have to put on your Sherlock Holmes hat, and if the LED isn't working, you have to just kind of look at all the connections, make sure the connections are correct, and kind of deduce and narrow down what the problem could potentially be. So sometimes it's code-based, and if it's code-based, then it'll usually tell you. But like with Vanessa's issue, it didn't say it was a problem, I don't think. It's just like a space missing. So it won't always tell you.
Cool.
So yeah, it's kind of like a bit of a mystery sometimes that you kind of have to solve and look at all the clues to determine what's going on.
Sounds cool. Sounds good. Thank you.
Sure. Okay, so why don't we go ahead and just do some more code additions here. So let's say we wanted to, instead of just have it on all the time, let's say we want to blink the LED every so often. So after digital write, we could say add a delay. Let's say, I don't know, 1 second. So I'll add some comments here. Delaying. So LED stays on for 1 second or 1000 milliseconds. And then let's do a digital write 3 of low. Let's say turn off power to LED. And then let's do another delay, and it stays off for let's do half a second. LED stays off for half a second. Okay, so we could check our code, verify. success. Awesome. Another thing that you can look at is that this web environment uses color coding to tell you what's what. So a function setup and loop are going to be green. I guess the space doesn't matter there. And then functions inside of setup and loop are going to be orange. So yeah, if there's a space, then it's going to turn black. That way you know that something's up. So that's a little indicator. So you want it to be orange. And then the variables are going to be blue, and the pin numbers are going to be or the values in the functions are going to be like a brownish color. And then comments are like grayed out. So color code is helpful to know when it comes to programming for the Arduino. Okay, so now when we upload this, we should get the LED to blink, turn on for 1 second, turn off for half a second. And then just kind of loop through that constantly. So mine is going. So it's blinking, turning on for a second, turning off for half a second. Is that working for everyone? Cool. Dope. So feel free to play with these values. So let's say I want it to be on for I don't know, 200ths of a second, and off for 100th of a second, or 100 milliseconds and 200 milliseconds. So I should be blinking like crazy. So just playing around with those values and the delay gives you different outputs. So you can blink the LED very quickly or do it really slowly depending on the delay that you add to it.
Professor, my jumper cables are not black and other. They're all these other colors. They're orange, green, and blue.
Mm-hmm. The color really doesn't matter. It's all the same on the inside. The color just kind of helps you visually indicate what's what. But they all work the same. Okay, so the next thing we're going to do is kind of play around with both an input and an output. So let's unplug our Arduinos from the computers so it's not getting power. It's usually a good idea to unplug any sort of power source while you're plugging things in and playing around with the circuit, so no short circuits could happen or anything like that. So it's always good to remove the power source when you're editing the circuit itself. What we're going to add to this, you can keep it as is, but we're just going to add to it. We're going to add a button, a little momentary switch button, which is going to straddle the center of the breadboard. So there should be a button in your kit with 4 prongs. So there's 2 sides to this button. We're really just going to use one side. So let's straddle the center of the breadboard. We're going to use let me take a look at the resistors that came in your kit again. So one side of that button is going to be connected to power. So the power rail. Then the other side is going to be connected to input 2. So there's a resistor attached to the side that's connected to the Arduino, and that's called a pull-down resistor. I'm going to use this resistor. It's brown, black, red, and gold, and that is let me test to see how many ohms it is. So that's 1,000 ohm resistor, I think, about. So the reason why we do this is probably not 100% necessary all the time, but it's called a pull-down resistor, and that is kind of pulling down the amount of current or the amount of power that's being sent back to the Arduino. Because with a button, with like a switch like this, a very simple switch, all we need is a little bit of current to be sent to the Arduino, a little bit of power to be sent to the Arduino for it to know that the button was pressed or not. So we don't want to send too much power to the Arduino, otherwise we might fry out the board. So that's why we use a pull-down resistor to pull down the amount of power, the amount of current that's being sent back to the Arduino when we press the button. So that is going to be plugged into ground, and to the side of the button that is plugged into the Arduino.
Does the wire in the two have to line up with the button?
The wire and the what?
We have it here.
Yeah, so the wire and the button and the resistor should all be on the same row.
Okay.
Yeah, it doesn't really matter if it's in front of or behind it, just as long as it's on the same row. So here is what mine looks like.
Which resistor did you use?
So it is 1,000 ohm resistor. So it's brown, black, orange, and gold. You guys have that one? Let me check here, your kit.
Yeah, I found it.
Okay, yeah. It should be, let me just double check to make sure it's the same. It looks the same, but who knows. All right. Let's try and do the code now and see if that's working, and then we can debug if we need to. So this is what we're gonna do. So in setup, we are going to add a pin mode for 2 and set that as an input. And then in our loop, we're going to ask a question. We're going to say, ask if digital read 2, which is the input where the button is, equals high, essentially if the button is pressed. Then we want to turn on the LED that's plugged into input 3 by sending it a high value. If it's not pressed, if the button's not pressed, else, then we want to send it a low value, basically turning the LED off. So we're just making a little light switch. When you press the button, it turns on the light. When you release the button, it turns off the light. Okay, so let's go back to our code. Let's see. So I'm gonna duplicate this one. So if you click on the name, duplicate sketch, and you get a copy of it. Let's just rename this one button demo. Okay, and let's just delete this stuff in the loop. And I'm going to add a pin mode 2. Set that as input. And then in loop, we're going to do an if statement. So if digital read 2 equals high, then we want to send pin 3 digital write 3 a high value. Else digital write 3 low. So we can check that. Looks good. And then we can plug in the board. It's probably still blinking. It's fine. And upload our new code. Oh, so I got an error message because my board isn't selected. So I have to select the board, then upload the code. Okay, and let's try it. Okay, it's working for me. When I press the button, the LED turns on. You guys having luck with that too?
Just typing in the code now.
Okay. Let me change the name of this one too. Let's call it Blink Demo. So let's just add one more component to this. So let's add another LED. And we're basically just gonna, when you press the button, switch between the two LEDs. So one's gonna turn on, the other's gonna turn off, and vice versa. So let's maybe do like a red and green one, if you want. Like a stop and go kind of thing. And this one that we're adding is gonna be plugged into output 4, pin 4. So let's go ahead and set that up. So we need another resistor too. Again, I'm going to use the 220 ohm, which is the blue one in your kit. And that's hooked up to power. So we're basically just doing the same thing we did before with the other LED, but we're just adding a new one to the circuit. And that LED is going to be plugged into pin 4. So I have my green LED here, just connected to pin 3, a red LED with my resistor there, which is then connected to pin 4, and then I'm also connecting ground to grounds for the LED. So the same thing I did with the green one. I'm doing the exact same thing with the red one, except instead of pin 3, it's plugged into pin 4. So this is the code. So again, we're just adding to the last one that we had. So now we have another output for pin 4. And then in the if statement, we're just going to say, okay, digital write high for pin 3 and digital write low for pin 4 when the button is pressed. When it's released, we're going to switch it and digital write low to 3, turn it off, and then high to 4, turn it on. So it's just going to switch back and forth. Let's go ahead and go to our code. Say, okay, add new pin mode 4. It's going to be an output. And then in our if statement, we're going to say digital write 4 low, else digital write 4 high. So it's kind of like a stoplight a little bit. So make sure your Arduino is plugged in. Select the Arduino and the port that's plugged into, and then upload the new code. Okay, let's try it. Oops, mine was wrong. So I plugged the power side into the ground side by accident for the red one. Okay, now it's working. Here's mine. When you press the button, it just switches between the two LEDs. So stop, go, stop, go, stop, go, stop, go, stop, go. Cool.
Yeah, earlier I didn't realize one of the wires was slightly not in.
Yeah, that's always irritating when it's like a little thing like that. So, but that's gonna happen. So you just have to check like everything if something's not working, and just kind of go down the list of the possible things that could go wrong, and then eventually you'll figure it out. So I kind of like to think of it just as like a scavenger hunt, or like a, solving a mystery or something. So it's a little less painstaking if you come at it in that direction. So yeah, so obviously you can like play around with it more by adding more code to it. So if you wanted to like have it blink as well, you can add a delay in there as well and kind of play around with that. You can add more lights. If you wanted to add like a yellow light, like an actual stop sign or stop light, you can add a yellow light too, and then have more buttons, or just have it timed to like go through all the LEDs. So there's a lot of possibilities that you can kind of play around with. But yeah, I just wanted to kind of go over the basics, make sure that you understand how to code the programming environment, understand the board, understand how to upload code to the board, understand how to connect the board to your computer and have it communicate. So yeah, that was kind of the whole point of today's class, is just get you comfortable with Arduino, get you comfortable with the programming environment, and start actually designing some circuits and uploading some code to it. So feel free to kind of play around with it. That's basically the assignment for homework this week. Yeah, you could also kind of experiment with existing products. So this is my wife worked at Yahoo, actually works at Yahoo again. They just kind of went back to being Yahoo. But they had these big buttons that they were giving out to all their employees. And essentially it's just on the inside of this massive button is the same little button that we've been working with today. So it's just kind of, when you press that big button on the top, it's only on the inside pressing a little button, the same kind of button that we were working with today. So you could hack this and use this as a way to control your LEDs or control something else on your circuit using the Arduino, because essentially it's the same components that we use today for the button anyway. So think of things that you can like buy at the dollar store, or the things that electronics that like your friends or family are throwing away. Those could be hacked to use for your own projects for this class. So yeah, I rarely throw away electronics. I have like a bin of old electronics that I just keep and kind of use for projects down the road. So it's a good way to recycle stuff too and not throw away things. So another thing that is new to Arduino is they have an IoT cloud option that you could play around with, and an app that goes along with it. So IoT stands for Internet of Things. So that's like your smart thermostat, your like garage door opener that is connected to an app, your alarm system that is connected to an app. Those are all Internet of Things because they're all connected to the internet. Devices in your house that are connected to the internet. So you could actually do that and create Internet of Things projects that are connected to the internet that you can control using the Arduino IoT Cloud app. So if you wanted to do something like that, you can do that too. I haven't played around with it yet, so I'm not too familiar with it, but it's something that you can use for your projects if you want to, and I'll help as much as you need me to, and I'll figure out how to get it working too. So yeah, that's another thing that you can play around with that's fairly new. So for homework, I basically just want you to review what we did today and come up with a just very simple yet creative application for using digital input and output. So it could be similar to the last assignment where you made your own switch, your own button. So it's come up with like an interesting way to kind of play around with a digital input and output using what we talked about today. So once you've put something together and you're happy with it, then I want you to document it like always and put it up a blog post based off of the interesting creative application that you came up with for digital input and output. Okay. So that is all I got for you guys today.